7.3, other reflections of a point. So we've got reflecting over the line y equals x, and I found that we're forgetting back from algebra that you have y equals mx plus b, which is called slope-intercept form. So when I have y equals x, that's really y equals 1x plus nothing. So it has a y-intercept of 0, and it has a slope of up 1, right 1. And so it makes to where it hits every corner of the box. I'm trying to do this without a ruler. And so this is our line of reflection. So we are trying to take the point -8, -5, and reflect it over this line. I'm hoping you remember from the last unit, what we need to do is figure out the slope. It looks like I could go down 1 and right 2. So I need to reverse that pattern, and then I'm going to go down 2, right 1. So I know this is not very big. And that puts me at -5, -8. Okay, so what's happening is your slopes are going to be negative reciprocals when you reflect over this diagonal line. You won't have to do this. I just want to show you what's happening. What you need to know is that when you're reflecting over a y equals x line, you're switching the coordinates. So they just flip-flop. Okay, the next one is reflecting over y equals -x. So that is the same as y equals -1x plus 0. So it would go this way instead, because you're going down a box, right a box. So something like that. Our point now is at -8, 1. So if I wanted to reflect here, I could count, so the same as what we did here, I could count though diagonal. So see how this is 1, 2, 3. It's kind of hard to tell. It looks like 4 boxes away. I would gonna go 1, 2, 3, 4 diagonals away. And so that would put me here at -1, 8. Okay, or again, if I want to do slope, I could go up 1, 2, 3, 4, 5, right 2, and then I could go up 1, 2, right 1, 2, 3, 4, 5. So again, that puts me right there at -1, 8. So again, you don't have to do this, but knowing the rule and knowing what's happening really helps. So what you do in this one, you switch and negate. So we're swapping, but now this becomes a -1 and this becomes a +8. Okay, the next thing that we need to know how to do is reflect over the origin. So we'll take a point -5, -6, which would be here in quadrant 3. And this one you could think of, how do I get to the origin to reflect it over here? Well, I could go up 6 and then right 5. So I could do that again, up 6, right 5. So see how these points are equidistant away from the origin? So that puts me at 5, 6. And our rule here says to negate only, you don't swap. It's really the same as rotating something 180 degrees because you're rotating it on a straight line, which is 180 degrees. So you're just negating, not swapping. Okay, so again, knowing the difference between these. So these, they get switched when you reflect over a diagonal line, but over the origin they don't switch. And then the last thing is reflecting over a point. We've got the point 7, -8 being reflected over another point 4, -5. Let's draw that real quick. 7, -8 over 4, -5. Okay, I'll show you visually first, and then I'll show you what you could do without a graph. So I want to reflect over this point, just like I kind of did over the origin. Think, how do I get to this point? Rise over run. I go up 1, 2, 3 boxes, and then right 1, 2, 3 boxes. I would do that same pattern again of up 1, 2, 3. I think I said right, sorry. left, 1, 2, 3. So that would put me at 1, -2. This has to do with translations. So asking yourself, from 7, nope, I don't want to come there, from 7 comma negative 8, I'm going to leave a space. How are we getting to 4, negative 5? 7 to get to 4 would be a left 3, a minus 3. And then negative 8 to negative 5, you're actually going up or adding 3, right? So then that would be my rule. So what I could do is take the point 4, negative 5 and do that same rule again where I would subtract 3 or go left 3, which puts me at the 1, and go up 3, which would put me at negative 2. So that's how you could do it without a graph.